Harvard astrophysicist Avi Loeb has just released an analysis and its conclusions are staggering. It suggests that 3IA Atlas, our third interstellar visitor, might have catastrophically exploded. Not just cracked, not just shed a bit of material, but shattered into at least 16 distinct fragments, creating a cosmic fireworks display we're only now beginning to witness. This isn't speculation. This isn't a what. The evidence is real, the data is quantifiable, and the implications are profound. Think about what that means. We are for the first time potentially watching the fragmentation of an object from another star system in real time. As it happens, we are witnessing hard evidence of its disintegration captured right now through our most powerful telescopes and space-based instruments. But that's where the official simple story starts to get complicated. Because there's another possibility, one that doesn't fit neatly into our textbooks, one that raises even more unsettling questions about what this visitor truly is. And the clock is ticking. We are in a race against time to find out which narrative is correct before 3I vanishes back into the interstellar void forever. To understand what's happening, you need to see the evidence. Let me walk you through it. The story begins not with the explosion but with the discovery. It was July 1, 2025. The Atlas Survey Telescope system in Chile flagged an object. It was immediately recognized as something extraordinary. This was only the third confirmed interstellar object ever detected by humanity following the enigmatic Oumuamua in 2017 and the comet 2I Borisov in 2019. The designation 3I literally means third interstellar object. These visitors are rare beyond measure. The odds of detecting even one are minuscule. Now we had found three, and this third one, was about to do something that defied all conventional explanation. By late August 2025, just a few weeks later, the James Webb Space Telescope captured detailed infrared images of 3I Atlas. Webb's most sensitive instruments revealed something unexpected. At first, it looked like a comet. It possessed a massive carbon dioxide gas coma extending at least 348,000 kilometers in radius. That's nearly as far as the Earth is from the Moon. But here's where the data started to become strange. The abundance ratios of various elements were skewed. The iron-to-nickel ratios were unusual. The molecular composition didn't quite match the textbook profile of a typical cometary visitor. Then came the anomalies, the kinds of observations that stop astronomers in their tracks. First, the acceleration. As 3EY Atlas approached the Sun, it began accelerating in ways that defied standard gravitational physics. Harvard's measurements showed what scientists call non-gravitational acceleration. The object was moving faster than the Sun's gravity alone could explain. The radial acceleration reached 1.1 times 10 astronomical units per day squared. To put that in tangible terms, the comet experienced a cumulative acceleration of about 94 kilometers per day squared at perihelion. An object already traveling at over 150,000 miles per hour was mysteriously speeding up. Second, the mass loss. This was the big one. Between early August and its perihelion on October 29, the mass loss rates of 3 Atlas increased from roughly 330 kilograms per second to nearly 2 million kilograms per second. That is a 6,000 times increase. The comet went from shedding less than 1 million tons per day to ejecting approximately 2 million tons every single second. And third, the color. Any astronomer will tell you that comets typically appear yellowish or white as solar radiation illuminates their dust and gas. 3I Atlas was becoming increasingly blue. This suggested an unusual composition, possibly dominated by certain metallic compounds reflecting light differently than standard icy nuclei. We had an object that was speeding up, shedding an impossible amount of material and changing color. The mystery was getting deeper, and the mainstream explanation was about to be tested. So, what could possibly explain these anomalies? The acceleration, the impossible mass loss, the strange blue color. The mainstream explanation was straightforward. Mass loss, cometary outgassing. As 3I Atlas heated up approaching the Sun, its volatile ices sublimated, shooting jets of material outward. The reaction force from this outgassing would accelerate the comet forward. It's a mechanism we've seen before. Halley's Comet does it. Comet Neowise did it. This seemed to settle the matter, a natural comet behaving with natural physics. Except the numbers didn't add up. This is where Avi Loeb, the Harvard astrophysicist, began running his calculations. His math revealed a fundamental, glaring problem. At perihelion, the Sun delivered 700 joules per square meter per second of energy to 3I Atlas. For a natural comet to sublimate enough ice to produce the observed mass loss rate, that 2 million kilograms per second, it would need to absorb an enormous amount of solar energy. Loeb's calculations showed that the required absorbing surface area of 3I Atlas would need to be at least 617 square miles. That's a sphere roughly 14.3 kilometers across. And here is the problem. The Hubble Space Telescope had already imaged 3I Atlas back on the 21st of July 2025. Those images place strict constraints on the nucleus. Based on Hubble's observations, the nucleus could be no larger than about 1 to 2 kilometers across. Think about that discrepancy. The energy calculations demanded a surface area 16 times larger than what Hubble could physically observe. How could a nucleus grow 16 times larger in 3 months? It's impossible. There is, however, one plausible explanation that satisfies the physics: fragmentation. If 3I Atlas wasn't a single object, if it had shattered into, say, at least 16 equal pieces, each of those fragments would have its own surface area. These pieces would collectively provide the required surface area to explain that dramatic mass loss increase. The total surface area of 16 smaller fragments equals approximately 16 times the surface area of a single nucleus. The math doesn't lie. The 16-fragment theory perfectly explains the anomalies. Case closed. Or so we thought. This is the plot twist. If 3 Atlas simply fragmented like a typical comet nucleus under thermal stress, we'd expect to see a diffuse chaotic cloud of debris, a messy random explosion. Instead, something far more organized is happening, and British astronomers just captured it. On the 9th of November 2025, just 11 days after perihelion, British observers Michael Butner and Frank Nebling captured images that changed everything. These weren't casual observations. These were highly processed, carefully analyzed photographs revealing unprecedented structure. The images show 3I Atlas displaying what astronomers call an anti-tail formation, a tail pointing toward the sun, which is counterintuitive, but more importantly they captured not just one tail but multiple distinct jets. The main collimated jet structure stretched 2.85 million kilometers in the opposite direction. These aren't scattered wisps of material. They are organized, collimated, highly directed outflows. At least 7 distinct jets were visible, showing organized geometry. This doesn't look like a simple explosive fragmentation. This looks controlled. This is where Avi introduced his most controversial hypothesis. What if 3I Atlas isn't a natural comet at all? What if the organized jets aren't products of passive thermal outgassing, but active propulsion? Before you dismiss this, understand what he's actually arguing. Loeb points out that technological thrusters operating at high exhaust velocities would require far less mass loss to produce the observed accelerations. An alien technology could produce these non-gravitational accelerations while burning far less fuel than the 2 million kilograms per second we calculated. The geometrically organized jets, the anti-tail, they would all be consistent with directional thruster arrays. Loeb isn't claiming proof of an alien spacecraft. He's framing it as a scientific question. He's stating that if natural cometary physics cannot adequately explain the observations, we must consider that the technological alternative fits the data better. And we are about to find out which theory is correct. The clock is ticking. 3I Atlas's closest approach to Earth is scheduled for the 19th of December 2025. The Hubble Space Telescope and the James Webb Space Telescope both have new observational campaigns planned for November and December. These observations will be definitive. They are the tiebreaker. If Hubble and Webb imaging reveal multiple distinct objects, a field of 16 or more tumbling fragments, then fragmentation is confirmed, a stunning but natural cometary event. But if they show a single intact nucleus still producing these extraordinary organized jets, we will enter genuinely uncharted territory. Our first interstellar visitor, Oumuamua, was strange because it showed no cometary activity at all. The second, Borisov, was perfectly normal. But 3I Atlas is the strangest of all. It's a visitor that's forcing us to expand our entire analytical framework. This window of opportunity is finite. By next year, 3I Atlas will be gone, racing beyond the outer solar system, never to return. The observations we conduct in the next few weeks represent humanity's only opportunity to study this visitor. For the first time in human history, something from the stars has come to us, an object we can measure and study in real time. It's either demonstrating a remarkable new natural phenomenon or it's revealing something else entirely. The fragments are real. The jets are real. The accelerations are measured. What created them will determine the truth.